Alright. I know the camera angle is kind of messed up, but it's so that the table can be seen pretty nicely. It's also because this desk is smaller that I'm currently working on. But hopefully that shouldn't be a big deal. Alright. We're gonna just go and do a Leetcode problem. However, I gotta bring out the big guns. Once again. The keyboard! Kinda gotta move this. Keyboard. And keyboard. This mouse, maybe I'll just move it off to the side. Okay. I'm just going to do one Leetcode problem, and then the rest of the day I have some other stuff to do, so I'm not going to worry too much about making the stream long. Hello Nafi, yes, it's been a while. It's been over a week. Yeah, the last few days of before I left were, I think that was 4 days before I left, was the last stream. But also, yeah, you know, during that time I had to set up a lot, and then now we're here on the weekend. Hello Copy Multi, it's good to see you too. Right, so let's start off again with monkeytype. We're in a different room, by the way, guys, if it wasn't obvious enough. Let's see. Equals question mark. Whoa, I'm not getting my question marks right. Semicolon. How do I do a semicolon again? Let me think. Okay, yeah. I don't have my cheat sheet on me, so I have to go off my own memory, or muscle memory I should say. Equal question mark where owner key equals question mark semicolon I'm also not sitting in an upright position. Problem is, when I sit in an upright position, I'm kind of too close to the screen and you can't see my face. Self obj value con. I'm gonna go to a hackathon event later today, so this is gonna be a semi-short stream, just finishing at least one Leetcode problem, because I kind of made myself need to do that. Found an app called Liftosaur where you can write code to make your own program. Interesting. Write code to make your own program. As in, like, oh, in the sense that it's like monkey type practice. Liftosaur. It uses its own interpreter for building your program. The most powerful weightlifting planner and tracker. Is this it? Weightlifting. No, this isn't it, right? Oh no, it is. No, wait. Type your program here. Oh, a program as in, okay, a program as in your actual, as in your fitness program. Okay, I understand. Okay, this is not bad. I will use this. Like, I think this looks pretty good. A web editor exists. Kevin, yo, what are you working on at Amazon? Okay, so I can't say the specifics, right? Because yeah, it'll breach certain rules. However, I'm working at Amazon Redshift, which is a data warehouse. Okay. Now, yeah, I think I'm hesitant to go beyond that, obviously, because I work there currently, and I'm pretty sure it's like trade secrets. Technically. So this is its own programming language, and you can build out your program. Interesting. There are own scripts to well-known lifting programs like Jeff Nippard, RP strength programs, and personal Liftosaur subreddit. I see. For sure. Because I know GZCLP, because I've done it for a bit, but then I stopped. Yeah, I remember. That's all I remember. I did it for a bit and then I stopped. How many years of work experience do you have? That's a good question. Let's say, back in 2021 was when I first started. Yeah, basically back in 2021. So it's not, it's not long. It's like 3 years. But like part-time work, and other freelance stuff and like startup stuff. So I've been through, like, I've tapped into each little realm of income, you could say. But yeah. But also considering, it's 3 years on and off. The other thing is, it's part-time. It's also I started this back in first year, basically second semester, working at a small little agency, building workflows for businesses, and you use like UI to build these workflows, in the sense that you're using Zapier, you're using another tool called Make. Yeah, those are the tools, I guess. Okay. I could do one more of these, but I could also not be bothered. Just go to a Leetcode problem. Thanks, Tiraj. Appreciate it. So I could do a 1D dynamic programming problem. Let's open up Obsidian. We're gonna say, yeah, we're gonna try and do one of these. Word break. You know what? Today I might choose to do a Leetcode 150. Now I could do a graph problem. I really could. Okay, but a min cost climbing stairs. This is an easy problem. Surely I can figure this one out. All right. Given the stuff that I've done for dynamic programming already, could I figure this one out? Maybe. So we'll have a go. This is the one that we'll do today. See how long we get to do it. All right. We'll see how long it takes. In terms of like camera positioning, like here's the thing, I can't get my face in the picture exactly. Unless maybe I sit further down. I think this might work. Okay, like this is kind of like a middle ground, okay. I'm looking upwards now, also. On my screen, okay. Let's have a look. So you are given an array of integers. Wait, Vimium. Okay, Vimium doesn't work. Yeah. You are given an array of integers cost with cost I, where cost I is the cost of taking a step from the ith floor of a staircase. Really? After paying the cost, you can step to either I plus 1th or I plus 2th. Really? You may choose to start at the index 0 or the index 1. Interesting. Return min cost to reach the top of the staircase. Just past the last index in cost. Just past the last index in cost. So, do you need 2 then? So I can think of this as a decision tree problem, which can then be converted to a a decision tree problem is a tree. It'd be a DFS problem likely, and then if it's not, I guess efficient enough, then you can go to a memoized approach or a bottom-up dynamic programming approach. Or is it a top-down dynamic programming approach? It may be a top-down, and then we can make a bottom-up. If you do make a bottom-up though, it means you go from the bottom, or should I say the top of the staircase, and then you can either -1 or -2 your whole way down the staircase. And this would be a bottom-up approach, I think. But the question is, how would you do that from a dynamic programming perspective? You might, as in a bottom-up dynamic programming perspective, you might have to start from the very end, or the top of the staircase, and -1 or -2. And then you know how many steps it will take to get to that top position, or how much the cost is to get to that top position from that point at that time. And then you would -1 again from, say, the last step before the very top, and you would say you -1 if that cost is less than the cost of the 2 steps, then you would update that value. If that isn't the case, then you wouldn't update it, and you would continue counting down, going down the steps. So you would need to keep okay, dynamic programming questions. I understand. Okay, this is just a rant now. Dynamic programming problems. I understand why they're so good. and why Google does them. It's because these dynamic programming problems have a lot to talk about. You can build these backtracking decision trees, or you can build, if it's not efficient enough, the dynamic programming top-down approaches, which uses this recursive idea from the decision trees. And then you can optimize this to a bottom-up approach, maybe only needing an array. And again, you can optimize it again to make it, instead of an array memoization, into a two variables memoization, perhaps. And that does make sense. I feel like we can reach this two variable memoization. Okay, so anyway, alright, I've opened my eyes now, but that's like my thought process. Copy multi. My Insta got hacked 3 days ago. Someone changed my Gmail, then its password, and then he sent back my account a day later. His email as Google notified it. Can you find out who did this? I can't find out who did this for you. I'm not a hacker. Yeah. I program. Plus, if I were to do it, I wouldn't do it on stream. It wouldn't make sense. You know what I mean? Okay. So, alright, do I want to go straight to a memoized approach? I'm going to go straight to a memoized approach. In that case, we're going to have a memo, or I should say a DP, that consists of zeros times n plus 1. So this is just zeros everywhere, but because we're trying to find the min cost, maybe this 0 isn't very good of a choice. Assuming that you can't have a value that is, a cost cannot ever be greater than 0. Yeah. Sorry, cannot ever be less 0, then we know that we can use this -1 as our invalid case, or not filled case. So let's see, what should we do here? -1 n plus 1. Okay, we can start from the very top of the DP, so we're going to go for I in range of n plus 1 minus 1 minus 1. So n plus 1 is, might not be correct, right? N minus 1 is the actual starting value. So n minus 1 minus 1 minus 1 gets you all the way to n minus 1 to 0 inclusive. Then from here, if you have some DP, you started at this ith position, technically you could start from n, go to, so this is going to be equal to 0 originally. So if n if I is equal to n, then dpi is equal to 0. Alright? And then you would continue. By the way, what's your plan on Christmas? I have none. I'd literally be working. I think, other than that, like, whatever else comes up, invitations and connections, I wouldn't mind. But I wouldn't be flying back to, say, Melbourne to celebrate with family, I guess. I won't be, that is. Okay. What else are we gonna have to do here? So that's fine. Now, when you're at dp of the next thing, you're gonna equal to dp of I minus 1. And then I plus 1 is gonna equal dp of I minus 1. So this is plus. Okay, wait. Plus the cost of this position. So cost of this position is always going to exist here because we've taken the case where I equals n already. And the problem here is also we need to take the max, I believe. Sorry, the min of this and dp of I. Okay, but the min, then that means this has to be some initialized value, maybe to math.inf, because this just makes it easier. And this is going to be the min of this, or dp of I. Okay, dp of I plus 1. And then you go and do this all the way down, and then I think that's right. You return dp of 0, I think. N is not defined for sure. N is equal to len of cost. I see. Okay, last question. You wear contacts? No, I don't. But my eyesight isn't good, I will say. So okay, so we got problems here. I might go print dp and just see what this looks like. Your output is 1. Hold up. What has happened? Expected output is 2 for sure. How come it's not printing? Okay, here's the problem. Print, I'm just going to print I as well. So we start from 210 for 210. When you do 2, I would expect this to be so that's infinite, or dpi minus 1, or I plus 1. Shit. I plus 1. I plus 1. And we're saying this is going to be minus. Gotta have a look now. No, that's alright. Copy multi, you can ask him. That's fine, dude. Okay. It works for one, doesn't work for the other. Let's understand why. Cost 1, 2, 3. From this point, everything is 3. From this point, everything is... So you can jump it to 5. Wait, so my output was 4 when you expect 2. Wait, why do you expect 2? 1. Oh, right. So there seems to be a step skipped. Mooch, how did first week go? Not bad. Thank you, Razine. Okay, yeah, it was a lot of networking, I will say. Mooch, it was a lot of networking. Didn't know a lot of new people, I would say, so it was pretty fun. And then also getting onboarded, and onboarding is actually pretty tough, I will say also. So because it's a big code base. That's yeah. It's gonna take some time to onboard. Okay, so let's see. Let me make this more clear. So print dp, and we're gonna start from okay. Everything is infinity. Okay. So I gotta print dp here. I'm gonna say like print dp. Okay. Run this just to see it better. So infinite. Okay, now starting from 3, you know that you're gonna have 0. Then from 2, you know you're gonna have 3. From index 1, you have a 2 here. So this should be updated to 2. So min of okay, so I think I've done something wrong. Right. I've done something wrong here. So dp of I could be I plus 1 plus the cost, or it could just be hold on, dp plus I. So if we start from 3, sorry, if we start from 2, you know there's a 3 cost. 0 plus 3 is 3. Or it's whatever exists there, infinity. So in this case, it's going to equal to 3. And then the one next to that is going to equal to I minus 1 is going to equal to the cost plus the cost of I. Should I say the cost of negative I? Alright, dp. Right, okay, think. So cost of I, let me think. Cost of I could go 1 step, 2 steps. Technically, how am I meant to think of this? Could go minus 1 or minus 2. I'm so close. dp of I plus 1. So basically the previous number plus this cost, and the previous number plus this cost, or whatever's already in this position. And so when you get to 1, all the same position. You're going to have 3. You're going to have 3. And then 0. I'm gonna have 3 because at this position, sorry, so when you reach 0, you get to -1. -1 is 0. If -1 is 0, when you reach 0, it's -1 is going to be 0. Sorry, -1 is going to be 0, and then what? What does that tell me? It means you're taking the cost of the 3. And then the dp of that. So I should extend this by 1 more. If I extend that by 1 more, it's tough. And +1. Right, index out of range. And +1. Index out of range. Everything needs a +1? Maybe? Wait, what am I shifting? I'm shifting the dp +1. Man. So it starts from here. The dpi +2 should exist. Sorry, I+1. Huh? Why we're still having DP issues? If we start from n plus 1, alright, that shouldn't matter then. Right, so that doesn't matter. You added the 0. But then when you get to a point min, dpi plus 2 doesn't exist. So this is still 1 then? This is still 1. Still 1. This is minus 1. This is minus 1. And this is 1. Like, this is the problem that I just had before. Cost of I. Index out of range. So this is I minus 1. And this is I minus 2. Five versus 2. So when you reach 0, start with 0, you know, you can get 3 and 2. Well, technically for the I, we only care about it from I minus 1. 3 and 3. 4 and 4. There's something that I'm missing. Fuck. Alright, we're gonna look at the solution. Fuck this. We messed this up pretty bad, to be honest. Holy, the simplicity. Space optimized is pretty cool. Let's see. Dynamic bottom up. This is something I was trying to do. You start from 0. You make them all 0. And then for I in range of 2 to n plus 1. Now 2 to n plus 1 is inclusive of 2 to n. Then that means dpi is equal to the min. Wow. Sounds simple. Sounds like it's very simple. dpi minus 1, cost I minus 1. So this is like going from bottom to top of the staircase, that is. So you start from 2, you don't start from 1, because you can minus 2. Okay, I can understand that. But damn, fuck. That's taking way too long. Alright, that means I can restart this, to be honest. However, yeah, no, that's right. Okay. Let me not look at this and try and do it. So n equals len of cost. dp is equal to 0 times n plus 1 for I in range of 2 to n plus 1. We're gonna have dp of dp of I equal to the min of certain ranges. So we're gonna have dp of I minus 1 plus the cost of I minus 1, dp of I minus 2 plus cost of I minus 2 minus. Are we happy? Return dp of n plus n, dp of n. Azan Haida, are you currently working at Amazon? Yes. First week as an intern. It's pretty good. Not gonna lie, it's pretty good. I can understand all of these solutions. Holy shit, this is 19 minutes.
Hey everyone, welcome back, and let's write some more neat.
Yeah, we're not gonna watch it. That's right, guys. We're calling it a day. For this stream, 48 minutes. I've never seen an intern start in December. Is it for a winter internship? Well, actually, it's because I'm in Australia. So this is for a summer internship. So yeah, so this is a summer internship starting in December. Basically goes through all my holidays. So yeah. Alright. I'm going now, guys. But thanks for joining. And talk more on Discord. So peace.